Ladies and gentlemen, thank you for watching our project video. My name is Yiming.
And I'm Ziyin.
In this video, we'll give you the whole introduction and summary of our project, what we should know and what we have done. So let's begin. Here's our presentation outline. In this video, we'll introduce the pipeline of our project, some knowledge what we should know. We'll also give you explicit illustration of our architecture and achievements, and finally, conclusions. For the project introduction, there are three main points. Why we choose this topic, project overview, and our objectives. So why we choose this topic? Firstly, as we know, Chinese is second popular language in the world, and more people get interested in it. Is Secondly, this project is closely related to what we learned in this class, EE599 Deep Learning, and it combines Chinese culture with academic knowledge. Finally, it actually has a great potential application, speeding up the font designing. So for our project overview, I'll give you the pipeline for our project. We use two font style character images as our dataset. We use the source style character image and the target style character image as input in our CycleGAN model. So after training, we can use the target generator to realize the function that we give a source style image, and it can generate a character. It can generate the same character in the target style as an image. So, what are our project objectives? There are two main points. The first one is we try to reproduce the model and performance according to a reference. So, which is that given a source style font character not in the training data, the model can generate the same character with target style font. Secondly, we try to improve the performance by adjusting dataset and model. Okay, I believe that you get a general view of our project. I'll explain what we need to prepare. For the preparation, we need some basic knowledge. What is the basic knowledge? It is a basic CycleGAN and basic GAN knowledge and CycleGAN. So we already learned GAN in deep learning class, and the GAN has a basic the generator and discriminator. The basic loss function is here as follows. For the CycleGAN part, the total loss function has two paired GAN loss and a consistent loss because it has two generators and discriminators. Now we need a consistent loss to combine these two architectures. So, besides our basic knowledge, our main reference is as follows. Generating handwritten Chinese characters using CycleGAN, written by Paul Zhang. You can search it you can Google it online. So, our running environment, our model requires a lot of computation power. So, we set up AWS P3.2 X large computing engine, which is enough for us to train our model. Okay, here's our architecture part. For architecture, there are two main parts. The first part is dataset, and second one is network architecture. So for the dataset, there are two font styles, same here as our source style image and HW252 as our target style. Target style has approximately 3,700 characters, and we use 30% of them as training originally, according to a reference, and the rest of them as test. What we need to do to pre-process the data is is that transforming characters into images and resizing them into 128 by 128 pixel images. Here are the examples of our source font image and target font image. These characters in Chinese is I, meaning hey. So these two characters are the same with different styles. A human font designer must have learned a lot of fonts in different styles before he starts to create a new one. That means the designer should be an expert. So what we need to do is to augment our dataset. try to overcome the problem of dataset deficiency. So the augmented dataset should have more and more data. We we use source and target style images with more training set. According to this intuition, we use 29 different digital fonts except HW12 252, which is the target style we want to finally to generate. This contains chi, semicurve, cursive, hey, and etc. And many basic styles. Because a human's handwriting is typically a combination of those basic styles, we pair these fonts in characters. So unlike the dataset used in original Cyclogan, we get a paired dataset. The, the amount of the samples is over 1 million, so we have enough data to overcome our dataset deficiency. Here are the examples of our target font and source font. The target font has different we use HW252 as our target font. Source font has different input font styles. For the network architecture part, here let my teammates introduce those parts.
Hi everyone, I'm Ziying, and it's my turn to let me introduce our used network architecture. So the basic architecture is a cyclogram. As you can see in the slide, the cyclogram has two competing parts. Each part has a generator and a discriminator, and the total loss for the cyclogram is consists of two parts: two GAN adversary losses and one cycle consistent losses. But to utilize the augmented dataset we mentioned before, we need a refinement of the structure of generator. We borrowed the idea from auxiliary GAN and the domain transfer network. Here is an image to illustrate the structure of the structure, and we call it ZGAN. It has a bottleneck generator. Also, it has a style embedding matrix, and so we train ZGAN with paired data regarding the augmented data set. And there are in total 4 losses to be optimized: a classical GAN loss, a style category loss, an encoding constant loss, and a fake real image L1 distance loss. We believe these 4 losses can ensure a good result to generate a Chinese character. So after training ZGAN, we can get an expert GAN. So we then enter phase 2 training. In phase 2 training, we first initialize with 2 copies of both structure and weight of ZGAN. Then we freeze the encoder and embeddings in both sides, because at this time they should have a strong ability to fetch the most abstract information of a character or font. Then we add a selector to combine all style embedding vectors. Because as we stated above, we think of real person's handwriting is typically a combination of basic styles. So these selectors can be trained. We train the cyclogram now on the unpaired data. We mentioned the most first. So phase 2 training is a fine-tune process. It shares the weight from the phase 1 training and therefore can be viewed as a transfer learning. This slide will give you a sense of what we have achieved. So the four images are the ground truth for 4 different characters. Then these four images are generated by original cyclogram. You can see this the structure of these characters has been destroyed. And the last 4 images were generated by the augmented cyclogram. You can see all these 4 characters are valid and keep the structure from the ground truth. So they look much more similar with the ground truth. So we come to the conclusions. We found that using only unpaired data and corresponding loss may not provide sufficient guidance in training a GAN network, and paired data and losses may work better. Um, so, so when your data set is deficient, you'd better have an augmented data set and carefully carefully design the loss function. Another point is that if you don't have enough money, don't do deep learning. We burned up almost all credits on AWS to train the model. But if you are a millionaire, just forget about it and run on your model. Thank you. That's all.